Alrighty, so here we go. We're going to do our first lesson for Algebra 2. It is a review, so if this feels a little bit out of character, hey, well, you probably just had geometry. So we're going to review Pemdas, which is our order of operations, and then also solving, just so that we can make sure we are all back on the same page. So, I am going to do this a little old-fashioned and just go ahead and write it out as we go. The idea is that this is practice, and so you don't need to take very comprehensive notes, but you do want to make sure that you at least remember what we are doing here today. So, first thing that we will go over is our order of operations, okay? And so, your order of operations is traditionally referenced as PEMDAS, okay? And so each of these letters does represent something. Of course, you've got your little phrase of, please excuse my dear Aunt Sally, or I have absolutely no idea what else people have done. But anyway, so the idea would be that P would be your parentheses, which we'll go over a little bit in a second, but parentheses do include brackets, okay? They do also include your little, squiggly brackets, if I can draw those. It also includes your radicals, which is actually why a lot of people actually call this GEMDAS, because they'll call these grouping symbols. Anyway, weird. The next one is going to be your exponents, which, however much you pay attention, exponents are actually radicals. So, hey, that would actually go under exponents. But moving on, we're actually talking about things that have little tiny numbers or powers. So, that's your exponents. Then, of course, we get to multiplication and division. And so in multiplication and division, you always move left to right. And so this is where it gets a little confusing, because you may think that it's like this order of 1, 2, 3, 4, and you have to kind of follow that order in order to get it right. But it turns out that if we were going to order them, we'd actually group them as 1, 2, and then step 3, and then step 4. Okay? Because it turns out addition and subtraction is also moving left to right. So we'll go over some examples to kind of go along with that, but I do want to fill in the rest of this, so let's see if I can fit in multiplication here, and division, and addition, and subtraction. Alrighty, so that's your order of operations, and again, this is when you are solving something. So again, we are using this, sorry, not when solving, when you are checking an answer. For what you're working through, and when you're just working through any like calculator operation. So, used when checking an answer. So we're going to go ahead and do some examples, especially those that might get a little bit tricky. So, first thing we're going to just review a little bit is the fact that when you have something like 14 divided by 2 times 4, first of all, we are pretty much never going to write our division signs like this ever again. So most likely what would happen is you would end up with 14 halves, and then that would be multiplied by 4. Or, of course, because we get fancy, you could do 14 halves times 4 with parentheses. Either way, the idea is that you have only division and multiplication. And so we are going to work from left to right. So if we work from left to right, the first thing that we're going to do is 14 divided by 2, which is going to get 7. And then we're going to multiply that by 4. And so we get 7 times 4, which is 28, and yay, there's our answer. A lot of times when this is introduced in Algebra 1, we kind of talk about making this kind of pizza going on here, okay? And so you get your answer there at that first bite. But if you had gone ahead and tried to work in the order of Pemdas, and so if you think back to Pemdas, it turns out that it looks like multiplication is first and division is second. Okay, but if you tried that, you would end up getting 14 divided by 2 times 4, but you'd be doing this piece first. So 2 times 4 would have been 8, and then you would have had 14 divided by 8, and 14 divided by 8 is like 1.75 or something. So you can see that you'd actually get a completely different answer, okay? But again, this is the wrong way because it is not using the order of operations. And because there are two ways of doing it, we had to, mathematicians, develop the proper order of doing it. So we have a rule, and it's PEMDAS. So we want to make sure that we don't think of it as a first and a second, but a left to right idea. Okay, so the next example that we're going to do here kind of goes over that same idea, but now we're doing addition and subtraction. So if we go ahead and use the same numbers, we're going to try 14 minus 2 plus 4. Okay, so the right way that we're going to do this is working from left to right. So we're going to take this first operation of 14 minus 2 and we'll get 12. And to that we'll add 4. And so 12 plus 4 results in 16. And that's your answer. However, if we did it the wrong way, we would have started with, instead of 14 minus 2 plus 4, PEMDAS, if we write it out, clearly says addition first and then subtraction second. And so if we go with that idea, then we actually need to do 2 plus 4 first. So if we do 2 plus 4 first, we get 6. And 14 minus 6, it turns out gives you a completely different result of 8. 8 is not 16, and that's because you did it the wrong way. Yes, sadly, there is a wrong and right way, and this one did not get it going. All right, so let's not do that way, because then we would all get completely different answers. Okay, so let's follow the rules. Good idea. All right. Next thing that we're going to do gets a little bit more complicated because this is where it gets fun, like a little puzzle. Sorry. If it's not fun to you, I'm sorry. So if you think back to kind of, again, Algebra 1, when you were first introduced to a lot of this stuff, you kind of looked at something like this and said, oh, okay, blah, 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 blah. But remember that we don't write division like this anymore. So if you do see this problem now, you're actually going to see it written as 6 minus 4 squared divided by 2 and all of that times 6. Okay, so again, it kind of sets up the fact that you're working left to right because you would hit this division first in this clump before you even think about multiplying. So kind of when you write it as a fraction, which is division anyway, you end up kind of grouping it to go left to right properly anyway. All right, so if we take a look at this and think of our PEMDAS, we're going to start with parentheses and exponents, and as you see, we do in fact have parentheses and an exponent. So we're going to do parentheses first, so 6 minus 4. 6 minus 4 is going to result in 2. 2 is still going to be squared, still divided by 2, and still times 6. Yes, I do show all of my work because, of course, I want you to be able to see what I'm thinking, but also it helps you, if you do it this way, remember the process. So the next thing, of course, is exponents, so we're going to go ahead and take the number 2 and bring it to the squared power, which means 2 times 2. So we'll end up having 4 divided by 2 times 6. Now again, as we look at it, we're going to do multiplication and division, but remember it's left to right, and so the leftmost point is going to be 4 divided by 2. So 4 divided by 2 results in 2, and 2 times 6 finally gets us our answer of 12. Again, if you did it in a completely different order, you may not have gotten 12, which of course is a problem since we're all going to be following this solving order of operations rules. All right, kind of done with those. So now we are going to talk about how we start to move backwards, okay? So what happens is Pemdas backwards becomes SADMAP. I know, lame, but that's what we're going to do. So SADMAP is used when you are solving. And pretty much all of Algebra 2 talks about solving, okay? It is pretty rare that we're going to go back to the SADMAP, okay? It's rare that we're going to do PEMDAS because we are usually solving in Algebra 2. So we're going to do SADMAP, and again, that's used in order to solve, meaning what does x equal? Or whatever the variable happens to be. All right, so we're going to try one out, and again, we're using the opposite because we're going to solve. One way that you know that you are solving is because the directions might say something like solve for x. They might say find x, which of course is always funny because then people say, hey, it's right here. Okay. And then let's see. That's all I got so far. So if we're going to solve for x, and we're given our problem here in example 4, that 2x plus 3 equals 9. Getting used to writing with my stylus pen here, so that is a terrible looking 3. All right. So in order to do that, depending on what you have done, a lot of people will do this kind of train tracks idea, so you kind of split it up, because if you ever cross the line, you do have to do an opposite operation. So if we're going to solve for x, solving is always your opposite operations, and because it's opposite operations, it's going to be SADMAP instead of PEMDAS. So if we take a look at SADMAP, the first thing it's telling us to do is actually subtract or add. So if we look at what we have over here, we have addition. And we always read left to right, okay? So if I look after the addition, I see that it's saying that we had 3. So our opposite operation, subtracting. And of course you're showing that you're doing it on both sides. It's an equation, so it's nice to be equal, all right? So if we subtract 3, we get a new value of 6 and 2x. If you don't remember, hey, turns out that this is 2 times x when it's right next to it. So now we've moved on to division and multiplication, in fact, multiplication. But of course, if we're going to undo what's happening here, we're going to divide by 2. And so now we're left with our end result, that x happens to be 3. Let's say that you're really interested and you want to know if 3 actually is the answer, because maybe you made a mathematical error. What you would do is go back up and plug your 3 in for the x. So you would check with a 2 times 3 instead of x plus 3 and see if that equals 9. This is where you're actually using PEMDAS because you are checking your answer. So in that case you have 6, 6 plus 3 is in fact 9. Yay, 9 is 9, who knew? Okay. So you don't necessarily have to check all of your answers, but pretty much if you, especially on a test or a quiz, want to get all the points, hey, let's go ahead and do it. All right. So, solving. Very exciting stuff here. All right, so the next example that we're going to do here is this one. I guess we're solving for n now. I've just decided that's a new letter. That's okay, because it could be any letter you want. I always do M because my name is Maggie, but it could be X, it could be, again, whatever it is that you would like to be the variable. It's varying, doesn't matter. So we've got x divided by 2 plus x divided by 7 plus 2, and we want to see what x actually is. Now, of course, there's those of you that'll think, okay, let's go ahead and do a guessing game, because I know it's probably a whole number. Okay, but we're not going to do that because there are literally millions of answers, billions, infinite answers, so we're not going to go ahead and sit here and try all of them. We're just going to go ahead and get it, okay? So no more guess and check here. We're actually just going to do it. So if we go ahead and do it, remember that the first thing we want to do in SADMAP is subtraction and addition, and I see that there's addition here, so we're going to subtract. If we subtract 2 from both sides, we're going to end up with continuing our x over 7, but a positive 2 and a negative 2 cancel, and so technically, if you wanted, you could write plus 0, but that seems a little redundant. So our other side has the fact that we are now equal to 0, and so now you get to ask yourself, what divided by 7 makes 0? Or, because you see division and you're really excited about process, you're going to multiply both sides by 7, because what we do to one side of an equation we have to do to the other side. And now we realize that a number divided by 7 times 7 undoes itself. So this is where you would say canceled. And so now we have the x left over with, well, 0. Again, if you wanted to at the beginning, you could have noted that you needed something plus 2 to equal 2, and the only thing that you could get would be 2. 0. But, hey, 0 it is. All right. So again, there will be a homework assignment for this, and all you need to do is go through and solve using Pemdas, and then switch over and solve using SADMAP to get a variable instead of just an answer. So, our next example here is this one, 7x plus 3 equals 49. All right, there are 2 ways of solving this, so those of you that love distribution, hey, yay for you. But those of you that are sticking with SADMAP, which is lovely too, you are going to focus on your subtraction and addition. So if we take a look at here, you notice that there are these parentheses, which is lovely, and there's some addition inside of it. But what happens is if this is inside of parentheses, which is all the way at the end, we have to save that until the end. So technically we're kind of looking at this and this as 2 separate pieces. And so the only thing that's actually happening here is multiplication. So if you think of this as your group, all right, the only other thing other than that group is this multiplying by 7, so we have to undo that. So that's where you say, okay, if this is multiplying, then I'm going to undo that in order to move to the other side. So I'm going to divide everything by 7, which is nice because 49 is divisible by 7, in fact, 7 times. So, moving back over to the other side, turns out that your 7 being multiplied by this random quantity and your 7 being divided into that random quantity literally leaves just the x plus 3. Now, since there's nothing actually outside of this x plus 3 anymore, it is the same as writing it with parentheses or without, so those are the same phrase. And so now we actually do get back to subtraction and addition. So if you look at this process and reference SADMAP, you're thinking this was completely wrong. But that's because the parentheses made this, what you would assume, first step actually last. So it moved them to the end. All right, then the next piece is going to be undoing that 3. So we'll subtract a 3 so that we can get rid of the fact that we're adding and subtracting the same number. And we get an x that gets to be equal to 4. And again, those of you that are good at guess and check, super, you maybe thought of that at the beginning. But that's not what we're looking for, because eventually there will be very long and complex questions that we are going to need to use these rules for. So, x is 4, yay. All right, the next one is going to be a little bit more complex. So this one here talks about combining like terms first and then solving. Ooh, and there's a negative number involved. Okay, so when we look at this one here, before we do a whole lot, we actually want to go through and use Pemdas, okay, to see if we can go ahead and combine anything that is alike. So again, before we even try to use SADMAP, we're going to combine like terms and then move forward. So like terms have either numbers with numbers or the same letter with the same letter. So our like terms is an 8x and a 5x. This is actually a positive 5x, so don't forget that anytime you are trying to combine like terms, you always want to include this symbol, either addition or subtraction, with the term behind it. So if we're combining like terms, here we go. We have 8x's and 5x's, which actually makes 13x's. Still have a subtracting 21, and still have a negative 15. So again, not much changed except that everything that was in green became this one here, 13x. So then we go ahead and try our SAD map. And so we're looking for addition and subtraction. And so in that case, there is a negative 21, and so I'm going to add 21. And of course, since it's an equation, I need to be equal, and so to both sides, I will add 21. Adding 21 to both sides cancels your 21, and so if you really want, you could write plus 0, but that's really not helpful. And so we bring down the 13x, and that's now equal to the addition of this, which is going to be, what, 6? Okay. So then we go ahead and solve our last step, which is technically 13 times x, and so we're going to divide both sides by 13. You can, of course, write your division symbol, but we do have to start getting comfortable with the fact that division is actually a fraction bar, so it's okay. So if we divide both sides by 13, we end up with a terrible number. I say terrible because it's a decimal, and it's a decimal that goes on forever. So, either way, we're going to take 6 and divide it by 13, and end up with a decimal of about 0.4615-ish. Okay. So, of course, as you're sitting here thinking of this original problem, you're probably not saying, oh, I bet that x is 0.4615, right? No. So, again, that is where these steps that we have are going to be very helpful because you're going to actually be able to use them to get the right answer, or even though it's ugly. Okay. All right, let's try our last, we'll try our second to last example, 8. That is how I made an 8 today. Okay, so let's say that we have 10 y's, which again, x, y, doesn't really matter, and 4 y's plus 8, and negative 20. Super. So what we're going to do here is talk about Pemdas, but before we do that, we're going to combine like terms. Before we combine like terms, you may notice that we have these parentheses here. So we're actually going to distribute the negative and you're saying, how do you distribute a negative? Well, technically it is a negative 1, and that negative 1 is going to be multiplied into this first term, boop boop, and this second term, boop boop. So if we go ahead and distribute that, we're going to end up with 10y minus 4y minus 8. And all of that will equal negative 20. After we see if there's distribution, then we go ahead and see if we can combine like terms. So if we combine like terms, we're going to combine 10y's and negative 4y's and end up just having 6y's, which is a little bit easier to look at. Once we combine all the like terms, we get back to one of these two-step solving. And so in our SAD map, we're going to do your subtraction and addition, which means I'll add an 8 to both sides of the equation and end up with a 6y equal to negative 12. And then the opposite of multiplying is dividing. So we're going to divide by 6 to both sides. and end up with a y value of, I'll move over this way, a y value of negative 12 divided by 6, so negative 2. Yay! Again, probably not your go-to answer when you are trying to guess and check what's happening, so we need to remember that when you're solving, we got to look for any simplifications that happen with distribution, if we can combine like terms, and then we follow our solving with SADMAP. Alright, we have one more example. This one talks about moving things across the equal sign. So we have 7n minus 2 and then 5n plus 6, and they're equal. So what happens is we are going to be combining like terms. But unlike the last examples, when you had them on the same side of the equal sign, like we did over here, we now actually have them on different sides of the equal sign. So how do you go ahead and do that? You combine like terms by taking, doesn't really matter which one, but I usually pick the smaller of the two. So when I'm looking at 7n or 5n, I'm going to think of this as a positive 5n, and the fact that I need to move it over to the other side. So positive moving to the other side means that I'm going to need to subtract 5n. If I subtract 5n there, I'm going to need to subtract 5n here. And so 7n minus 5n results in 2n's. The positive 5n and the negative 5n are going to cancel. And so we still have a negative 2 from this side and a 6, which we could write as positive 6 if we really feel like it, but hey, let's just keep it as 6. Now we're going to do what we were doing before, which is actually still combining like terms, but in your SADMAP, that means we're doing subtraction and addition first. So if I see a subtracting 2, I'm going to do the opposite of that, which is adding 2. That'll cancel out the 2's there and give us a new value of 8. And then we have the same old 2n left over on the other side. Last step is usually division, so here we are. If this is 2 times n, let's go ahead and divide. And now we end up with a result of n at the value of, well, that's a terrible n, 4. Let's just go ahead and erase that n, because yikes. Alrighty, there it is. So, hopefully from today's notes, when we talked about PEMDAS and solving, alright, you're going to use PEMDAS traditionally when you are checking your answers. But we're going to use SADMAP when we are solving. It's usually for x when we're doing. Okay, so you will end up having an assignment starting on Monday, the next day that we have class, that goes over using PEMDAS, and then also has quite a few of solving for x. Because again, we're practicing. It's the beginning of the year. It's going to feel slow, but that is what it is. So, enjoy.